What is up, YouTube, and welcome to another video. In this video we're going to be taking a look at Redis, what it is, its key features, and how to run it. And then we're also going to be taking a look at how to write a small application that uses Redis as a data store. And if you like this video, be sure to like and subscribe, because in a future video we'll be taking a look at how to run Redis in a highly available manner with HA and replication. And then in a future video we're going to combine everything we've learned and we're going to run Redis on a service like Kubernetes. So without further ado, let's go. So what is Redis? Redis is an open source in-memory data store. It can be used as a database, a cache, and a message broker. It also supports a lot of different data structures, but we're going to take a look in this video at just basic key value stores. Now, Redis is one of those types of databases that has the most types of use cases. I've seen companies use Redis as a database for critical data, so they need high availability and they need replication. I've also seen companies use Redis purely as a temporary cache. So you can run Redis as a sidecar process to your microservice and basically allowing your microservice to cache data so it doesn't have to rely much on external API calls. I've also seen companies use the replication feature of the cache to move large caches around to different machines and distributed systems. Redis also has the ability for pub subs, so that allows different microservices to publish messages to Redis and then other microservices to subscribe to those messages and topics. So if you're new to this channel, everything I do is on GitHub. So if you go to my Docker development YouTube series GitHub repo, you can go down to a new series I'm doing on storage. In that folder, I have a Redis folder, and in here I have a README. This is everything we're going to be doing today. So we're talking about Docker, how to run Redis, the configuration, the security, the persistence, as well as writing an application to put messages into Redis. So be sure to check the links down below to the GitHub repo so you can follow along. So the first step in our README points to running Redis using a Docker image. Now, for those who know me, I like to use Docker for everything that I run. Docker allows me to create like this universal runtime and makes it really easy for me to run applications, so I don't have to worry about the dependencies and what I need to install, and it allows me to decouple my application from the host machine, so it doesn't matter whether I'm running Linux, Mac, or Windows. So if we head over to the first step, I have a link to the Docker hub for Redis, and if we go over there, we can see Redis has an official image and it has a bunch of different tags. So today we're going to be taking a look at Redis 6 and we're going to run a lightweight Alpine image. They also have very basic high-level documentation, which is good to get you going. So this talks about the security of Redis, how to use a Redis instance, so a very simple Docker run command, how to get persistence working, how to supply your own Redis config, and a bunch of other interesting information. Alright, so the first thing I'm going to do is I'm going to create a new network called Redis. So I'm going to say Docker network create Redis. That is because we're going to run Redis on this network and then we're going to build an application and run it on the same network. Now, usually when you're running Redis on something like Kubernetes, you need to make sure that your applications can talk to Redis. That's why it's important to run them on the same network. You can see in my Docker run command, I have a port that I'm exposing. This is the default port in order to talk to Redis. Now, there's no reason for me to expose this port publicly. I'm just doing it here to show you guys how to expose it, but our application will be running in the same network, so it doesn't matter if I expose it or not. So to run Redis, we're just going to say Docker run interactively. We're going to remove the container when it's done. Its name is going to be Redis. It's going to be running on the Redis network, so --net Redis. We expose a port and then we run Redis image and we run the 6.0 Alpine tag. So I go ahead and run that and we can see Redis is now up and running. So when you do this, Redis will run in standalone mode. It'll expose port 6379. It runs as PID1 and a bunch of logs showing it's healthy. Now, Redis is able to launch with a default configuration, but I always highly recommend to run it with your own custom configuration. Now, the way I'd like to start is head over to the configuration documentation. Redis has a very good document describing all the configuration, and where I usually start is it has a self-documented config for each version of Redis. So what I do is I go to the Redis version 6 config, and you can see here that it points us to a GitHub repo with all the configuration values for version 6. This is the default config that we can use for version version 6, and every single key value is self-documented using a bunch of paragraphs. You can see it's all self-documented in the config file. I highly recommend to read through the configuration file carefully before making any changes to make sure you understand the impacts of changing configs and what it means. So what I've done in my Git repo is I created a config folder under storage Redis where I have a redis.conf. This is the Redis configuration for version 6, and this is the exact configuration I got from GitHub that I showed earlier. So as I said earlier, Redis has a configuration built in, but what we want to do is we want to override the default config using a Docker volume and mounting in this Redis config that I've showed here. So what I'm going to do is I'm going to change directory to storage Redis, and then I'm going to run this docker run command. So I'm going to say docker run it, and I'm going to also pass in the name Redis, run it on the Redis network. But this is the critical change I've made. I'm basically going to mount in the config folder, this folder on the left here, into the container, and I'm going to mount it into etc Redis. I'm then going to start up the Redis Docker container, and I'm going to run Redis server as an entry point, and one of the first arguments it takes is the location of the config. So I'm just going to say /etc redis redis.conf. This is the config file that I'm mounting into that folder. So I'm going to go ahead and copy this, and I'm going to paste it to the terminal. So now you can see Redis has started up, and this time it started up with our own configuration. So now we can go ahead and dial and tune every aspect of Redis. Now that I have a Redis up and running, the first thing I want to talk about is a little bit around the Redis security. Redis should basically not be exposed to public traffic usually by default. This is because Redis instance does not have a password to connect, so anyone can connect to that instance. So what we want to do is we first want to go to our Redis config file that we created, and we want to go and change the default password. Now I've documented this here. This is the key that we want to change. It's called require pass, and then we want to set a password. So if you copy that key and you go to redis.config and you go and Control F and you go and find the value, you'll see that I've already set this now to a super secret, secure, strong password. You want to set this to a really strong password that all your applications can use to connect to Redis. So other than running Redis with a strong password, it's also worth noting that you should think twice before exposing Redis to the public. What most companies do when they run Redis as like a database or a cache is run Redis instances on a private network so your application can talk to it over a private network. Redis does have TLS support from version 6 as an optional feature, but you would need to enable it during compile time. So that means you would need to compile Redis yourself using your own Docker file and then turn TLS on. Now the next thing I want to talk about is Redis persistence. Now by default, when you're running Redis the way we've just run it, it stores its data in memory. That means when the container dies, all of your data in Redis will be lost. So it's very important to mount your data to a file system or to a volume to persist that data. Now Redis also has a document on persistence, which I've linked down here. Now the reason I've linked it is because there are two modes for persisting data in Redis. There's RDB persistence and there's append only file persistent modes. It's very important to take a read through this document to understand the advantages and disadvantages of each mode. At a very high level, the RDB mode provides a higher performance mechanism because Redis will take a snapshot of point-in-time snapshot and write it to a dump file that we can configure. We can then mount that into a Docker mount to persist that data. The append only file mode basically will log every write operation that happens to Redis. It'll append it to a file. So that guarantees higher durability because there will be minimal data loss if our Redis process dies. But that comes with a performance knock. Now Redis also provides the ability to run in both modes. So in this demo, I'm just going to show you how to run RDB mode, how to run AOF mode, and just run it side by side. Now to turn on RDB mode, basically what you want to do is come over to the Redis conf and search for dump. And you'll see there is a key called db file name dump.rdb. So you can change the file or location of this file in this config value. This will turn on RDB and will basically start writing at various intervals to that file. We can also customize how often we want writes to occur. To turn on append only mode, you can search the Redis config file for append, and you'll see a key called append only. So to turn it on, just say append only yes, and then you can also specify a file name to write those write operations to. Now I would highly recommend to go through the persistence document to understand the pros and cons, because there's also a section talking about what you should use, and the Redis community recommend for safety reasons that you try to use both of the persistent methods. Now if you you don't care too much about your data, you can just run an RDB mode alone. That'll just dump to file every now and again. RDB mode is also great to use for backups. So if you want to back up your database from time to time, you can just basically copy that file and put it into storage. So now that we've gone ahead in our config and we've turned on persistence, we've turned on AOF and RDB, let's go ahead and persist that data to a volume. So what I'm going to do is I'm going to create a Docker volume called Redis, and then make sure you change directory to storage Redis, because we're going to mount that configuration file. We're going to say Docker run, we're going to call it Redis, run it on the Redis network, and we are going to mount the config file into Redis. The next bit we're also going to do is we're going to mount a volume. So I'm going to mount that Redis volume we've just created, and I'm going to mount it into /data. This is the default place where Redis stores data. And then I'm going to run the Redis server image, and I'm going to point it to that config. So to run this, I'm just going to grab this command and I'm going to copy it to the terminal. And that's going to go ahead and write the data to that volume. So basically, if we kill this container and start it back up, we won't lose any of our RDB file. So our RDB file will still be sitting in that folder, as well as our append only file. So now that we have our Redis running here, let's see what it takes to write an application that can access this Redis instance. So what I'm going to do is I'm going to leave this running in the background, and I'm going to open up another terminal. I also have all the steps listed out in this README, and I'm going to leave the source code in this folder as well so you can follow along. So to keep everything nice and clean and separate, the first thing I'm going to do is create a folder under the Redis folder, and I'm going to call it applications. And what I'm going to do is I'm going to create a new folder under that called client, and our application will be called client since we're going to be creating a Redis client. Now, usually when I write example applications, I like to use simple programming languages like Go. Keeps it very small. It doesn't matter what programming language you use, you should be able to follow along, since Go is very much like pseudocode. So what I'm going to do is I'm going to create a new file here called client Go, and we're going to write up some source code here to interact with Redis. So basically what I'm going to do is write a small web application that every time we hit that application in the browser, it's going to take a key out of Redis and increment the number and write it back. So it'll start at 1 and start incrementing it every time we refresh the page. So I'm going to very quickly walk you through what that looks like. So firstly, we're going to define package main. Then I'm going to import a couple of dependencies that we're going to need for our application. I'm going to import HTTP functionality because I'm going to be running a web server. I'm also going to import some logging library so we can log. And more importantly here, I'm going to import the Redis SDK. And then what I'm going to do is I'm going to expose a couple of environment variables to tell our application how to connect to Redis. So I have a Redis host, a Redis port, and a Redis password. Then I'm going to define a default value for our counter. This is the counter we're going to be reading and writing to Redis. Then I'm going to go ahead and create a main function. Now in this main function, there's a couple of things we're going to want to do. The first thing is we're going to want to go ahead and establish a Redis client using the SDK and pass in our options. So we can pass in the host, the port, as well as the password. We basically tell it to write to the default database in Redis. And you can see here I've basically created a local variable called R, and I'm just going to assign it into a global variable so that I can use this client in other functions. And the next thing I'm going to do is define a router for our web server. And then I'm going to also define a router method. So I'm going to say on get, we're just going to take in the response writer, the request details and parameters. We're going to pass it down to a function called increment Redis key. This is a very simple function that's going to be reading the value. If it doesn't exist, it's going to create it. If it exists, it's going to read it, update it, and write it back. And then what I'm going to do is just print a bunch of stuff to the terminal. I'm just going to say that we are running, and then I'm also going to start up my web server on port 80. Now let's go ahead and define that increment Redis key function. So I'm going to create a new function. I'm going to pass all those HTTP parameters down, and the first thing I'm going to do is go ahead and use that Redis client to read the key. The key's name is called counter, so we're just going to run rdb.get, and we're going to pass in the key we want. We also have to define a background context, which I can go ahead and define globally over here. Now in Go, we always have to assume that an error comes back and that we have to handle it. So what I'm going to do is I'm going to handle an error. The first thing is say if the error is equal to redis.null, meaning that there is no value from this key, or this key doesn't exist. So we need to define what we're going to do if this key doesn't exist. And then we also have to handle the error in case the error is not null. So what if there is some connectivity error or something that goes wrong? We have to then handle that. So I'm just going to say panic if that happens. And then in the else block, we can basically handle the scenario when the key comes back, so the incrementation of that number. So we're just handling three possible scenarios. One is the key doesn't exist, the other one is an error has happened, or there has been no error. So I'm just going to keep this very basic. So if the key does not exist, so what I'm going to say is I'm just going to go ahead and say RDB set counter. I'm just going to set it to 1, and then I'm going to say counter plus plus, and that's going to be all. If there's no error comes back and we have the key, I'm going to go ahead and convert that value from Redis that we've read at the top here, and I'm going to convert it into an integer into our counter variable that we've defined. I'm then going to go ahead and increment that number, and then what I'm going to go ahead and do is run the RDB set command and write that counter key value back to that key. So I'm basically writing the updated value back to Redis. And then finally, because it's Go, we also have to handle that error in case that error is out. And after all of that has occurred, I'm just going to write two things. One, I'm going to write the counter to the console so we can see it. And the other one is I'm just going to write it to the response, HTTP response, so we can see it in the browser. So now that we have our code, how do we go ahead and build this? Now again, I like to use Docker as my build environment so that I don't have to install all these dependencies of Go. So I have a basic step here. The first thing I'm going to do is I'm going to change directory to that client folder that we created. And you can see our application is defined in here. We have client Go. And what I'm going to do is I'm going to start a development container for Golang. I'm going to say Docker run IT. I'm going to mount all the source code into the container, into a folder called Go source. I'm going to set Go source to the working directory. I'm going to run this on the Redis network since we want to interact with Redis. I'm also going to expose port 80 so that we can hit our web server in the browser. And I'm going to run Golang, and I'm going to run 1.14 of that Golang version. So this is going to easily run my whole dev environment as a Docker container. So when I go ahead and run that, we can see now I'm inside the container and I have my client Go application right here. So I can go ahead and build it. Now to build it, I'm just going to say go build client.go. So you can see our build has failed because it cannot find any of the dependencies. So to get the dependencies, Go uses Git under the hood. So because I'm running an Alpine container here, I'm going to go ahead and install Git. And with Git installed, we can now go and download our dependencies for the application. So to start downloading our dependencies, I'm just going to define my application as a Go module. I'm going to say go mod init example.com hello. I'm just going to give it a name. That's going to go ahead and create a Go mod folder. You can see that over here, defining the version of Go and the name of our application. And then I'm going to go ahead and say go build client.go. That's going to go ahead and use the Go dependency manager and go and find all the modules we've defined. It is going to go ahead and download it, create a Go module, Go mod file and a Go sum file. It's very important to then check those two things into Git, and we can basically pull all of these things into a Docker file and create a container image. So now that you can see our build has succeeded and we have this little client application that's been defined here. So all I need to do now is go to my terminal and say /client, and now that's my application up and running. Now, before we test this out, let's put this all into a Docker file. So a Docker file allows us to universally package this up and all the dependencies into a container image, which makes it really easy for people to run, and it makes it easy to run in a service like Kubernetes. So what I'm going to do is I'm going to create another file in this client folder called Docker file, and here we're going to define what the Docker file should look like. So the first thing I'm going to say is I'm going to define a build image using the same image we just run for our build environment, and we know that Go uses Git as a dependency manager, so I'm going to go ahead and install that. I'm going to set my working directory as source, and now I'm going to copy in these two Go files, the Go mod and the Go sum file. I'm going to copy that into the source directory, and then I'm going to go ahead and copy the client.go, this is our application source code, into the source directory as well. Once we copied that in, we can just go ahead and say go build, and we can build that application. And to make the application lightweight, we can switch out to an Alpine image, very small runtime, and we can go ahead and copy out from that build image, we can copy our source client application, this is the binary that we've built over here, and move it to a folder called app client, and then we can just start it up with a command entry point. Now to build that, I'm just going to exit out of this container that we had before, and I'm going to go ahead and say docker build -t, and I'm going to call this image a Redis client v1. So I'm going to go ahead and copy that, paste it to the terminal. That's going to go ahead and build a container image. It's going to compile the source code, pull all the dependencies, properties, produce a lightweight binary, and then put that in an Alpine image that we can run. Now to run our application, it's very easy. Once we've built it, we can just say docker run -it, and we can run this on the Redis network that we've defined before. And then we specify a bunch of environment variables. We specify a host of what the host name of that Redis instance is, and then we also define a port and a secret password to talk to it. And we're going to expose port 80 since our application is a web app. So what I'm going to do is I'm going to take this command and I'm going to paste it into the terminal. And now we have a Docker application running on Docker, and we can go ahead and access it in the browser. So if I go ahead to the browser, we can see now we have accessed our web app, which has detected that there's no key in Redis. So it's gone ahead and added the first key as a value of 1. And as we increment this, every time we refresh, we're going to increment the value in Redis. So you can see we've gone up to 20. So now let's test out the persistence. So if I go to this terminal where we were running Redis before, and I go ahead and Control C out of it, Redis will basically terminate. And then what I'm going to do is I'm going to run Redis again by running the same command and mounting in the same volume. And when we do that, we can go back to our application and it should continue from the number it's left off. So you can see I've refreshed it, it's gone back to 21, and we've gone ahead and we can just continue incrementing the number. So we've persisted our data successfully in Redis. So hopefully that helped you guys get the basics of how to run Redis, how to provide your own configuration, and the basics of persistence, security, and configuration of Redis, and also how to develop a small application that accesses Redis to write keys in a key value store. Now, if you like this video, be sure to like and subscribe, because in a future video, we'll be taking a look at how to do Redis replication and run Redis in high availability mode. We'll also be taking a look at how to run Redis using masters and replicas, as well as the Sentinel services. And in a future video, we'll be taking a look at how to run all of that stuff on top of Kubernetes. So hopefully this video has laid out the foundation and the groundwork for you to learn about the basics of Redis. So let me know down in the comments below, how do you run Redis in production? And let me know what other sort of videos you'd like me to cover in the future. And as always, like and subscribe, and until next time, peace.